Hi all, today we are going to discuss about capacitance of three core cables. So if you take the cables, the cable construction will be like that. There will be outer periphery or the outer conductor which will be connected to ground, which we call as sheath. So this is we call as the sheath. Generally sheath will be connected to ground and there will be conductors inside. In a three core cable there will be three conductors. So now these are the three conductors. So I am just representing them by conductors. So now because these three conductors are at different potentials which are separated by some distance, but they are having a less distance when compared to overhead transmission lines. That's why we can tell that when compared to the overhead transmission line, the underground cables will have the more effect of the capacitance, because the main reasons, two reasons are there. One reason is the conductors are very near to each other, having different potentials, and the second reason is, so the whichever conductors are there, the conductors are separated by a dielectric material, unlike the case of overhead transmission line where we go for the air has a relative permittivity of 1. So here in the case of this, with the dielectric material is used whose the permittivity is very high. The relative permittivity is very high in the case of cables. So as the relative permittivity is more, so automatically the capacitance is more in the case of cables. And second one, the distance of separation between the conductors is less. So due to this also the effect of the capacitance is more. That's why it is very significant to study the effect of the capacitance on the cables. So let us see how the capacitances will be formed. So now the capacitance will be formed between the conductors because they are at different potentials. So we can tell the capacitance is formed like this. Similar way, because the sheath is at a ground potential and conductor is at some higher potential, similarly the capacitance will be formed between each conductor and the grounded sheath. So there is one more capacitance that is formed here. So let us take it as C1, C1, C1. I am assuming the uniform gap is there and the material that is used is homogeneous, so that all the capacitances are same. So now capacitance between the conductors, let us take it as C2, this also C2 and this also C2. I am assuming that they are equilaterally spaced. So total how much capacitances are coming? 6 capacitances are coming. So this I can represent in this form, because the sheath is at a ground potential. Sheath is at a ground potential. So we can tell that if you are taking these three conductors, these three conductors have two different type of capacitances. First capacitance is this one. So this capacitance I am representing by C2, 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 and there is one more capacitance. So this is the second capacitance. So these capacitance is connected like this. They are connected together. Second side terminals are connected together and they are at ground potential. So this is C1, C1, C1. So this I can represent in this form. So this delta connection I can convert to the equivalent star connection. So when you convert this to the equivalent star connection, it will become like this. We know the resistance becomes 1/3 in the case of star connection. So the capacitance becomes 3 times. So this will become 3 times of C1. This is C2, right? 3 times of C2, 3 times of C2, 3 times of C2. Now between these capacitances, again the capacitance is there. This is C1. There is one capacitance. This is C1. There is one more capacitance. This is C1. And these are connected together. And these are also connected to same potential. This is connected to ground. Or we can tell this is also connected to the neutral point. There is one more neutral point. So this, if you are approximating, so this you can approximate as consisting of like this. There are three conductors. So each conductor is having two capacitances to neutral. So I am just representing like this. So these are connected like this. So one capacitance is 3 times of C2. 3 times of C2, 3 times of C2 is there, and the second capacitance C1 is connected between the conductor and the neutral point or the ground point, because ground point is one where the potential is equal to 0, or we can call it as a neutral point only. We have seen the case of the capacitance per phase of the transmission line. You can please refer there. There I have told what does this mean. So now I can represent this as C1, this is C1, this is C1. Okay, this is what is the equivalent value. So from this I can write the equivalent as the combination of two capacitors in parallel, they will add to each other. So this will become C1 plus 3 times of C2. Similar is the case, this will be C1 plus 3 times of C2. And this will be C1 plus 3 times of C2. These are the three conductors and this is the neutral point. So we can tell the capacitance per phase I am representing by C0. So this I can write as C1 plus 3 times of C2. So let us take it as equation number 1. So here you can see, in order to calculate the capacitance per phase, there are two unknowns. One is C1 and the second unknown is C2. So in order to find this, two measurements are done. The first measurement is, the first one is bunch the 3 cores and measure the capacitance between the bunched conductor and sheath. So let us see how that it comes. So I am taking the cable again. So I am taking the 3 conductors are there. So these 3 conductors will form the capacitance like this. These are the capacitance. Here also one capacitance is formed. These are the capacitance. So it is asked we have to bunch the 3 conductors. Bunching means all the 3 conductors are short circuited together. These are short circuited together. They are short circuited. So once they are short circuited and we are measuring the value of the capacitance between this bunched conductors and the sheath, because remember the sheath is at a ground potential. So this value of the capacitance I want to measure. Let us take it as Cx. So because as these are connected together, so potential at this point and the potential at the second conductor, that means potential at A, potential at B and potential at C. So Va will be equal to Vb will be equal to Vc because both are connected together. So automatically the value of this capacitance, that is C2, so C2 will be equal to 0 because capacitance is formed due to potential difference between 2 points. As the potential difference is 0, or we can tell it is nothing but short circuiting of a capacitance. So the capacitance C2 will be equal to 0, only C1 will be there. So now A, B, C are at the same potential. So we can tell that this is A, B, C, they are at the same potential and there are capacitance C1. There is capacitance C1 and there is capacitance C1 here which is connected to ground. So we are measuring this value of Cx. So we can tell that Cx will be equal to 3 times of C1. Cx we got as 3 times of C1. Let us take this as equation number 2. So now we got the value of C1 because Cx divided by 3. Measure the value of Cx divided by 3. Now let us see how to calculate the value of C2. So for calculating the value of C2, what we have to do? We have to connect any 2 cores to the sheath and measure the capacitance between the remaining conductor and sheath. So let us see how does it comes. So again I am taking the cable. So in the numerical or in the exam also, whatever is given, try to draw the diagram first. So then try to do it. No need to mug up any formulas in the exam, because if you mug up, there is a chance that you will make the mistake. Just try to draw the capacitances, then follow whatever instructions are given. Even you can easily calculate in the exam also. So these capacitances are C1, C1, C1. So this will be equal to C2, C2, C2. So what is asked? Connect any 2 cores to the sheath. So let us assume I am connecting this core to the sheath and I am connecting this core also to the sheath. So this sheath is connected to ground. So now I am measuring the capacitance between this sheath that is not grounded and the sheath. So this is the value of the Cy we are measuring. So this I can represent like this because the sheath is connected to ground. So sheath is connected to ground, I am represented the ground. There is a capacitance C1 and this junction came, that junction point let us take it as A, B and C. So the junction A came. At the junction A there are 2 capacitances, one is C2 and second one is C2. Now the second side B and C are connected together. So one is C, another is B, they are connected together. So B and C are connected together, so automatically in between this B and C, so there is any other capacitance is there because this is connected to ground, this is connected to ground. So potential at C is equal to potential at B, so automatically the effect of this capacitance C2 can be neglected. So that's why we can tell that B and C are connected to ground here. This is what we get. So we have to measure the value of Cy. So where we are measuring the Cy? Across this C1, this is my value of Cy. Or this I can represent in this form. So this will be this point A I am taking as a base node. So this A is here. So capacitance is there, this is C2. There is one more capacitance C2. So these two are connected to ground. Now C1 is also, second side is connected to ground. So C1 also I can keep here. This is the equivalent value. So this gives my value of Cy. Or we can tell the value of Cy will be equal to C1 plus 2 times of C2. Let us take it as equation number 3. So from equation number 1, I can calculate the value of C1, equation number 2, that is Cx divided by 3. And similarly, I can calculate my value of C2 will be equal to, so I want to calculate the C2. C2 will be 1 by 2 times of Cy minus C1. This will be 1 by 2 times of Cy minus C1 is nothing but Cx divided by 3. Okay, this way we have to calculate this. Now, if you want to calculate what is the value of the capacitance per phase, so we have seen from the equation number 1, capacitance per phase is equal to C1 plus 3 times of C2. So, this I can write as Cx divided by 3 plus 3 by 2 times of Cy minus Cx divided by 3, or this I can write as Cx divided by 3 plus 3 by 2 times of Cy minus Cx divided by 2, or from this I can write C naught is equal to 3 by 2 times of Cy minus Cx divided by 6. So, this is my capacitance per phase. So, in some cases where the test figures are not available, one empirical formula is proposed by a scientist called as Simon. So, to give the approximate value of the capacitance, and this formula can be used only for the case of circular conductors. So, for the circular conductors, when the test data is not available, there is a formula that is used, that is given by C naught is equal to 0.299 epsilon r divided by ln of 1 plus capital T plus small t divided by small d. This will be multiplied by 3.84 minus 1.7 times of small t by capital T plus 0.5 times of t square by t square. So, this will be in microfarads per kilometer. So, what are the parameters here? So, parameters here, epsilon r will be equal to the relative permittivity of the medium, and d is the conductor diameter, and this capital T is the conductor insulation thickness, and the value of small t is the belt insulation thickness. So, this is for the conductor insulation thickness, and this is for the belt insulation thickness, because above the conductor insulation there will be one belt insulation also will be used. This we are going to see in the case of the 3 core cables. So, there I am going to discuss about different type of cables. So, let us take one small example so that this concept and how to calculate without remembering formulas will be clear to you. So, I am just taking one example, a 3-phase 3 core metal sheathed cable gave the following data. So, before proceeding, I want to tell you I am writing on a glass screen, so the handwriting doesn't come properly. So, I am keeping the complete handwritten material in the description of this video. You can please download the material from there. Here you try to understand the concept what I am teaching. So, remaining things you can please download from there. Okay, there is the test data that is given. So, first one is given that the capacitance between two conductors bunched with sheath and the third conductor is 0.8 microfarads per kilometer. So, the second one is given as the capacitance between bunched conductors and sheath is 0.9 microfarads per kilometer. So, now it is asked determine the capacitance between any two conductors, this is what is asked, and B, charging current per phase per kilometer when connected to 10 kV 50 Hz supply. And the part C that is asked, the part C is between any two bunched conductors and the third conductor if the sheath is insulated. Because previously we have assumed the sheath is connected to ground. Instead, if the sheath is isolated or insulated, in that case, how the capacitance will come? That is what is asked. Let us try to solve this. Because we know the value of the cable, so cable can be taken like this. There are three conductors. So this is the capacitance found between them. This is the value of C2, 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 and this is my value of C1. And this sheath is assumed to be connected to ground. So we can calculate the value of Cx, which will be equal to 3 times of C1. It is given here as 0.9. And similarly, the value of Cy, which is equal to C1 plus 2 times of C2, it is given as 0.8 from the data. So now I have to calculate the value of C0. C0 will be equal to 3 by 2 times of Cy minus Cx divided by 6. Or you can instead calculate from these two equations. If you know these two equations, you will no need to remember this formula also. So I am directly going with formula so that the calculation will be easy. Minus 0.9 divided by 6. So this one will be 1.05 microfarads per kilometer. So we got the value of C0. So let us calculate the capacitance between two conductors, because this is the capacitance per phase. So this can be represented like this. So I am taking a capacitance here, like these are the three conductors. So between these conductors we got the capacitance per phase. So that is capacitance between any one phase to the neutral, we got this as C0, C0 and C0. So if you want the capacitance between two conductors, that means between these two conductors, we can see here C0 is connected in series with C0, or we can tell when the capacitors are connected in series, the capacitance becomes half. So we can tell that the capacitance between two conductors, so this will be equal to this 1.05 divided by 2, this will be in microfarads per kilometer. It will become half of the value. So this will become equal to point. So what is the value that becomes? This will be 0.525. This will be in microfarads per kilometer. So this is the value of capacitance between two conductors. Similar is the case for the B. The charging current per phase is asked. So charging current I can call as charging current I is equal to V phase divided by XC. This will be nothing but V phase into 2 pi f into C0. So this will be equal to 10 into 10 to the power of 3 divided by root 3 into 2 pi into 50 into 1.05 into 10 to the power of minus 6. So this will be 1.90410 amperes per kilometer, because the current per kilometer, because capacitance is per kilometer. Now coming to the part C. So part C, it is asked like this. So let us try to visualize the diagram. So it is given there the value of C1. So this is the value of C2. This is the value of C2. This is again the value of C2. So these are the capacitances that are connected. So it is asked that the two conductors are bunched together. The two conductors are bunched together. Then it is asked to calculate the value of the capacitance between this two bunched. What is given here? I am just reading what is given. Between any two bunched conductors and the third conductor if the sheath is insulated. So these two conductors are bunched, and between these two conductors and the third conductor, it is asked what is the value of this capacitance, and it is also assumed that the sheath is not connected to ground, it is insulated. So this I can represent in this way. So this I can represent by, so if you are taking between this point, so this is one C1, this is another value of the C1, this is another value of the C1. So we can see here this point and this point are connected together. Let us take it as conductors A, B, C. So A and B are connected together, and the sheath is also connected. So the sheath, there are two things, one is C1, another one is C1, and this A and B, that point A and B are connected to this point. C1, C1 connected. Now this C2 is short circuited, so there are two C2. There is a value of the C2, there is another value of C2. So this is connected to point number C. So for point number C, there is one more capacitance. C1 is connected, that is connected to the sheath, that is connected back to remaining capacitances. So where the capacitance is found, I want the capacitance between this point AB junction and this C. So this is my value of capacitance which I want. So this value of the capacitance I need. So this value of capacitance will be, these two are connected in parallel, it will become 2 times of C2. These two are connected in parallel, it will be 2 times of C1, that is connected in series with C1, then that is connected in parallel combination with this C2. So I can write this as the total value of capacitance will be 2 times of C2 plus 2 times of C1 multiplied by C1 divided by 2 times of C1 plus C1. This is the value we get. So this will be equal to 2 times of C2 plus 2 by 3 times of C1. This will be equal to 2 times of 0.25 plus 2 by 3 times of 0.3. This will be 0.7 microfarads per kilometer. So this way you have to calculate this one. I hope how to calculate the capacitance for the 3 core cables is completely clear to you. If you still have any queries, you can leave your comments in the comment section below. I will answer to your queries from there. Thank you very much.